Hi everybody, welcome to week 7. We are almost done with the class. We just have 2 weeks left, and then you guys move on to whatever you need to do. So this is where you want to start. That if you have missing work, you want to make sure you start getting it in, because you don't have a lot of time left. So this week we are talking about graphing and the rectangular coordinate system. If you are going on to college algebra is about half the class graphing. So we're preparing you for that class. We're getting you started with some of the basics, but be prepared to graph when you're there. So there are more than 4 sections in Chapter 3. We're only going through the first 4. We're looking at the rectangular coordinate system, linear equations in 2 variables, slope of a line and rate of change, and then slope-intercept form of a linear equation. And then there's another section 3.5. We're going to introduce a little bit of that in the discussion this week, but you're going to be sort of guided. You're given the equation and kind of what to do. So the biggest things we're looking at is what the rectangular coordinate system is, graphing linear equations, understanding slope, and then slope-intercept form. So those correspond with basically the 4 sections of the text. So you've got your discussion this week, your ungraded practice assignment, the assignment, and then the quiz. So let's start with the discussion. Now, the discussion this week is different. So far through most of the discussions this class, they've been sort of open-ended, really getting you to reflect or do some research. This discussion is math-based. We had a little bit of that in some of the others where you had to show an example of a formula being used in addition to doing some research. This is almost entirely math-based, and this is what many discussions are like when you go on to college algebra. You'll have discussions like this in pre-calculus, so there are some like this in other courses as well. So you actually have to work through some math in the discussion forum, and usually these are applied with real-world situations, so that way you use real data, nobody has the same answers, but your process is all the same, so you can learn from each other. So this is really getting you started to see those kind of discussions if you move on to MA105. So the motivation this week is this discussion, you're going to be looking at the relationship between your forearm length, and I have a diagram there. The forearm is from your elbow to your wrist. It's not the palm. You got 2 parts on that diagram that are labeled, so not the palm part, it's the other part. That's your forearm. So we're looking at the relationship between your forearm length and your height. So the question we're discussing here, after you go through the work and then the things that you want to discuss in your applies, is are you able to use that forearm to predict the height? Is there an actual relationship between those measurements where your height predicts how long that forearm is, or vice versa? And so we're going to be looking at lots of data to see if there is a relationship. I will be collecting everybody's responses, plotting them all together to see if we can kind of predict it. And I'll be doing some statistics there. So if you're going on to statistics, you'll see how what we're working in this week applies to statistics. And then the other thing we're looking at is, can somebody else's measurements in their equation predict your own? You know, will you get the same answers? Will you get your height if you use their equation versus yours? So to start off, you have to do some measurements. So the first part is the measurement part. So you need to measure your forearm distance from the elbow to the wrist and make sure this is in inches. So it should be, I think, about 10 to 12 inches for most people. You need to measure your height in inches. So we have to be consistent on our units here. And then you want to do this for someone else. So you can pick somebody that's in your life, like a neighbor, a friend, a child, spouse, whatever. Or you can pick a classmate's data. You know, if they posted and they already have their thing, you can say, oh, this is their numbers, so I'm going to use those. So it's open-ended just as long as you have a second person, because you do need 2 sets of points in order to do this discussion. So once you have your measurements, that's where you start doing the math part. So you need to write 2 ordered pairs with the measurements, and I have them in order here. It's your forearm number, comma, your height number. And then you need to find the slope between your 2 points. So that's from section 3.3. Once you find the slope, then you are plugging in your slope and 1 point into this formula. So you're given the formula, you're plugging in your number for m, and then your x1 and your y1. So that's mentioned in 3.5. You don't have to read 3.5 to figure out this part because you have everything you need to understand it. Once from there, you're solving for y. So that's something you do in 3.4. So that should be familiar. And you actually had to do that when you were solving literal equations. And then you're graphing your equation and your ordered pairs so you can see, you can check to see whether your math is right. And there's a great website, desmos.com, for graphing. So I recommend using that. So the expectations of this for this discussion is all your work is shown and explained in math and in words. You're not just showing the math. You need to explain what you're doing. Tell us who you got the numbers from, what are your values, what is the slope, what does the slope mean, explain each step in words in addition to the math. That helps others learn, and then it helps you because you're like teaching us, which helps you understand things more. Make sure you have your Desmos graph shown at the end. Your replies, so they should be reflecting on the accuracy of using the equation to predict the numbers of others. Is it accurate for predicting your values? Is it not accurate? Also look for errors. If you see any errors in the work or suggestions for improvement, if you're saying, okay, this could be explained a little bit better here, or I'm not sure what this means, or here's a way you can organize this a little better, help each other out and help each other improve what you have. So that's the discussion prompt in a nutshell. So moving on to the assignments. Your ungraded practice assignment this week is from the Chapter 3 test. Just do problems 1 through 23. So if you have any questions on those, of course, you can reach out to me, attend a live session, tutor.com. There's lots of resources for you there. Your turned in assignment is 2 graded problems from the reading. Make sure, of course, you're showing all of your work. And I do allow resubmissions, so keep in mind, you've got only 2 weeks left to resubmit any work. All resubmissions have to be done before the course ends. Anything after that I cannot accept because once the course ends, you have no access. So everything has to be turned in by the end of the course. For your assignment, make sure everything's in order, everything's boxed or numbered. Genius Scan is a good app if you need help to turn it into PDF so you can get one file. Let me know if you're having any problems with any of that. And let's talk about your quiz. So you had your second exam last week. Now we're back to a quiz. So this quiz is covering what we're looking at this week. So you're going to have to look at graphs and be able to read a graph, understand what ordered pairs are, determine if an ordered pair is a solution. You need to fill in tables for linear equations, basically fill in the missing number. You're going to be graphing linear equations, so Desmos can help you out there. Finding x and y intercepts, finding the slope, explaining what the slope means, slopes of parallel and perpendicular lines, how are they the same, how are they similar, how do you determine whether a line is parallel or perpendicular, that sort of stuff. So, putting this all together, so for your suggested schedule, you can pretty much start the measurement part of the discussion immediately. Once you have gone through 3.4, then you have all the information you need to do the discussion. You have most of it once you finish 3.3 in the slope, so you can do a little bit at a time. On the discussion, I have it sort of split up, like you can find the slope once you do 3.3, do your equation for 3.4, that sort of thing. I did pick different practice problems here that go with each section versus the Chapter 3 test if you want a little bit more practice. And there is some extra time built into this schedule for catch-up time. So if you need to resubmit any assignments or you have any work missing, you can use those extra days to try to get all of that stuff in because you are running out of time. Our course ends, when does it end? October 5th? Is it the 5th? October 8th. So course ends October 8th. That is, of course, oh, that's my September calendar. Yeah, that is a Tuesday. So once it's, that day, Tuesday, midnight, you have no access. So everything has to be in by then. So if you have any questions, of course, move my slide, there we go. If you have any questions, of course, you can email me, you can give me a call. If you have any problems with the discussion, of course, definitely reach out. And I will talk to you guys at the next live session. Bye.